Hello everyone, this is a short tutorial for KIA4021 precast concrete and IBS. This is checking stress limits for precast hollow core slabs. This tutorial will be under course outcome number 2, analyze and design of components for precast concrete and IBS. Suppose we have a question worded as follows. So we have a hollow core slab with a 75mm thick topping. The tensile stress limits are negative 3.5 and compressive stress limits is 20.5. It's simply supported with 80 meters of length. We need to check that the top and bottom stresses are within their limits. The total weights of stage 1 and 2 are 6.4 and 7.2. And the maximum service stresses at top and bottom are 11.6 and negative 1.5. Our section moduli are shown as follows. So basically we have a hollow core slab with a 75mm thick topping. The dimensions of the other parts of the hollow core slab are not provided, but we don't need them because we have the section moduli. So what's a section moduli or section modulus? A section modulus is given by this equation. It's a moment of inertia divided by distance of the fiber to the neutral axis. So in this case, the most extreme fibers usually experience the most stress. So that's the distance that we take when calculating section modulus. Also, section modulus can be represented by this equation. We have the maximum moment subjected to that section or that structural element divided by the maximum fiber stresses. And what's the difference between EI and Z? E is the modulus of elasticity. It's a general term that describes the stiffness of the material. It's stress divided by strain. On the other hand, second moment of area, also known as moment of inertia I, is the bending stiffness of the cross-sectional shape of a structural member. So it's specific to the shape of that member. And lastly, the section modulus, it's the resistance to bending. So basically a higher number of section modulus tells us that it's more harder to bend, while a lower number indicates lower resistance to bending. So what are the stages mentioned in precast concrete? Stage 1 is when the topping is not structural, meaning that the topping has just been poured, while stage 2 implies that the topping has already reached its desired strength and it is forming part of the structure. So these are the section moduli for the top and bottom when the topping has not reached its desired strength yet, so it's not structural yet. So this is still stage 1. And these are the section moduli when the topping has reached its structural strength. So CO represents composite structural modulus, meaning it's a composite structure made from the hollow core slab and the topping itself. While the small letter C indicates that this is a stage 2. ZTC, we can also try to remember C here as the construction phase, when the construction has begun, or you could say completed, since the topping has already hardened. For stage 1, the total weight that we need to consider is the self-weight of the hollow core slab and the self-weight of the topping. These are the only two things which contribute to the weight and which we need to calculate. While on stage 2, the dead load and imposed load both contribute to our calculation. So this is for stage 2, the weight that we need to consider. So for the top, the stress limits that we need to check are given by this equation. Ft, stress at the top fiber, is equal to sigma T. Sigma is actually the maximum permissible stress limit for the top. So we need to add on what is the stress at the top at stage 1, and this is the stress at the top at stage 2. There's a small typo here. This should be 2. So this everything must be less than 0.45 FCK. What is FCK? FCK is the compressive strength at 28 days, and we reduce this by 45%. So 0.45 times the compressive strength at 28 days is the actual limit that we need to check. It must not be above this value. So notice that this part here is for stage 1 and this part here is for stage 2. And M divided by Z, if you recall, Z is equal to M divided by sigma. So if we switch around the variables, we have M divided by Z. That's why we get it like this. So the total, the permissible stress limits plus the stage 1 stresses and the stage 2 stresses. So this is basically what we're doing here. And for EC2 clause 5.10.22, this is for the bottom fiber stresses as well. And the small typo here again, this should be 2. Remember, one is for stage 1 and the other one is for stage 2. So this is the stress limits for tensile, if you notice, because at the bottom it's in tension and the top is in compression, since loads are placed above it. So FCTM is simply the mean tensile cylinder strength of the concrete itself, and there's no reduction for this one. And the negative only indicates that this is a tension value. So we have these two stress limits, stress equations, and we need to fill in the blanks, fill in the variables. So sigma T is negative 1.5, sigma B is 11.6. This is taken from the question itself. And these are the limits, 20.5 and negative 3.5. I think I made a small mistake right here. If you notice, these should be switched around. This should be 11.6 and this should be negative 1.5. So take note. Okay, so what do? We just fill in the values. But at stage 1, we need to find out what's the maximum moment experienced by the member at this stage. So we just, since it's simply supported, we just use WL squared divided by 8. So for stage 1, W1 is 6.4. This is given in the question. We get 51.2 kilonewton meters of moment. And for stage 2, this is 7.2. This is also from the question. And we get 57.6 kilonewton meter. So I think we have everything that we need. You just need to fill in the variables and see if they satisfy the stress limits or not. So how much do you get for FT and FB? Try and find out. See if you get the answer, and it should be, both of them should satisfy the stress limits. If it doesn't satisfy the stress limits, then you need to recalculate back, or perhaps you just need to report your findings as the stress limits are not satisfied. Okay, so that's all for the video. Thank you very much.